Hi, dear students. Welcome to this session on the analysis of previous Neet question papers. And this program is designed as to give you some idea about the topics on which questions were asked in the previous Neet question papers, right from 2017 to 2023. And also to give you some tips on those topics which are important, but till now questions were not asked on these topics, but still important topics on which questions may be asked in the future examinations. I know that you are coming to the last phase of your preparation for the examination. It's nearly 1 month and a couple of days remaining. So you will be engaged in intense revision process. And at the very first outset, let me wish you a very good success in the coming examination. Wishing you all the best. Let me begin the discussion in Neet Chemistry 2017 to 2023. Now, excluding the deleted topics, there are 10 topics identified: basic concepts in chemistry, atomic structure, chemical family, chemical bonding and molecular structure, thermodynamics, chemical equilibrium, ionic equilibrium, purification nomenclature of organic compounds, isomerism and reaction mechanism in organic chemistry, and hydrocarbons. And suppose you go through the previous question papers from 2017 to 2023, this bar graph in the slide will tell you how many questions were asked on each topic. On basic concepts in chemistry, there were 8 questions in total for these 7 examinations: 2017, 18, 19, 2020, 2021, 2022, 2023. That means 7 Neet examinations have taken place so far. So in these 7 papers together, on chapter 1, 8 questions were asked in various years. That means on average, 1 plus question is asked on this particular chapter. Coming to the second chapter, that is atomic structure, the total number of questions asked so far is 10. So it is something like 1.33 questions per paper from this chapter. In chemical family, altogether 9 questions so far. So it's again 1 plus questions in each paper based on this particular topic. And the next is chemical bonding and molecular structure, where you find as many as 20 questions being asked in these 7 years, which underlines the importance of this chapter. There is always a good chance of so many questions being asked on this particular chapter for the coming examination also. Coming to the next one, that is thermodynamics. 10 questions were asked till this time, average 1.33. In chemical equilibrium, 6 questions, that means 1 question per paper. And in ionic equilibrium, you have 9 questions being asked so far. Again, 1 plus 1 question. And if you combine chemical equilibrium and ionic equilibrium, you have 9 plus 6, that is 15 questions so far. So on an average, 2 questions per paper. And in purification nomenclature, you have 7 questions. That means at least 1 question per paper. And isomerism and reaction mechanism, you have 8 questions asked so far. That is 1 question per paper. And in hydrocarbons, you find as many as 16 questions asked so far. That means on an average, something like 2.4 questions per paper. Now, this is a general information about the gravity of the chapter in the examinations so far, to what extent the chapters are important, and how many questions from each chapter were asked for the previous examinations. Now, suppose we go through the type of questions which were asked. In 2017, there was no question on basic concepts in chemistry. But in 2018, there were two numerical questions. One was based on the reaction of formic acid and oxalic acid with concentrated sulfuric acid. And the question was about the carbon dioxide generated in the process and to what extent the neutralization with the sodium hydroxide. What is the amount of carbon dioxide alkali required for the neutralization? That was the type of question asked. And there was another question on the number of molecules calculation, that is the mole concept. So there were two questions, one a stoichiometric calculation and the second one a problem on mole concept. In 2019 also there was a numerical problem on mole concept. In 2020 it was mole concept in another form, that is calculation of the number of atoms in various samples. In 2021, it was an empirical formula, molecular formula question. In 2022, there was a stoichiometric calculation based on calcium carbonate hydrochloric acid reaction. And there was also a problem, a numerical question based on PV is equal to nRT, that is the ideal gas equation. In 2023, that is last year, there was a statement type of question in which there were statements relating to Dalton's atomic theory, mass of electron, neutron, etc. And then there was a stoichiometric calculation, again based on the decomposition of limestone to give carbon dioxide. So perhaps the question was about the carbon dioxide generated in the process and how many moles of carbon dioxide formed or how many grams of carbon dioxide forms and so on. So, if you summarize the type of questions which were being asked, remember mole concept is very important. You can get question on calculation number of moles, number of molecules, or number of each kind of atoms in a sample. So, questions of that type may be asked on mole concept, or you may be given various samples and you may be asked to find out which sample contains more atoms, which sample contains more molecules and so on. Or you may even get a question on what are the number of electrons present in a given amount of a material. So for example, suppose we are asked a question like this, on 1 gram of methane, what will be the number of electrons present in 1 gram methane? It's again a problem on mole concept. The molecular mass is 16. So 1 by 16 will be the number of moles. So 1 by 16 into 6.02 into 10 raised to 23 will be the number of molecules. And each molecule contains 5 atoms. And the number of electrons present in this molecule is carbon 6 electrons. And each hydrogen 1 electron. That means 6 plus 4 is equal to 10 electrons. So one molecule contains 10 electrons. So you can calculate the number of moles, then the number of molecules, and multiply by 10, you will get the number of electrons present in the particular sample. So questions of this type based on mole concept is a regular question. It is going to be a most probable question for even future examinations also. And then you have question on stoichiometric calculation. Of course, for these examinations, calcium carbonate hydrochloric acid reaction, decomposition of calcium carbonate, or a decomposition of limestone, or sometimes they give us the purity of limestone. What is the amount of carbon dioxide formed from 10 gram of 90% limestone? That may be the type of question asked. So anyway, you are likely get a question on stoichiometric calculation. And apart from these, you may also refer regarding reactions in solution to express concentration solution in terms of molality, mole fraction, etc. You may get questions on that, numerical calculations based on that, and also an important topic in chapter 1 is the concept of limiting reagent, and you may get a question on limiting reagent. So these are the important items in the first chapter which have been asked so far. And now coming to the next chapter, that is atomic structure. Of course, in all these years together, 3 numerical questions and conceptual questions, about 5 numbers, and statement type questions, 2 numbers. And in all the years, there were questions from atomic structure. So for the coming examination also, you are likely to get at least 1 question or even more than 1 question based on atomic structure. 2017, it was a statement type of question relating to de Broglie equation, Heisenberg uncertainty principle, and the energy of orbitals and the extra stability of fully filled orbitals, half-filled orbitals, and so on. It was a statement question. In 2018, it was a question on electronic configuration, again a theme-based question or conceptual question on electronic configuration, angular momentum, and quantum numbers. In 2019, it was to write the correct order of energy of the 4p, 5p, 5f, and 6p orbitals. That was 1 question, the correct order of energy of orbitals. And then there was a question about the hydrogen spectrum, the different regions of the hydrogen spectrum, and which series belongs to the visible region. That was a type of question. So there were 2 questions, one about the order of energy of orbitals, and then about hydrogen spectrum, the different parts of the hydrogen spectrum, and they belong to which part of the electromagnetic spectrum, and so on. Coming to 2020, it was a question, very simple question, to calculate the number of protons, electrons, and neutrons. If you are given a, so for example, an element, say X, with the atomic number A and mass number Z, what will be the number of protons, what will be the number of electrons, what will be the number of neutrons? A pretty simple question which any student can answer. Coming to 2021 questions, it was a question on the decay of the radioactive isotope of hydrogen. What was the particle emitted? That was a question from T13, that is tritium, the radioactive isotope of hydrogen. Which particle is being emitted during its disintegration? The answer was a beta particle. And there was another question, a numerical question based on the frequency wavelength calculation of the radiation that is emitted during the transition of an electron from one particular level to another particular level. So for example, n is equal to 3 to n is equal to 1. If the radiation is emitted, what will be the wavelength, frequency, etc. of the radiation emitted? And there you will have to use the expression for energy of an electron in the hydrogen atom, and a problem based on that. It is a routine type of problem. You prepare that. That's very important. Such questions are often repeated. Coming to 2022, it was a question based on the shapes of the d orbitals. Of course, the s orbital is spherical, p orbital dumbbell, but coming to d orbitals, all the d orbitals do not have the same shape. So the question on d orbital shape, that is important. That was a question. Problem relating to the radius of Bohr orbit, calculation the radius of the Bohr orbit of a hydrogen atom, or it may be a He plus atom, or it may be a Li2 plus atom, and so on. Expression for the radius. And I would suggest that you study the expression for energy of electron, the expression for the radius of the Bohr orbit, and the expression for the velocity of electron, and also the expression for the threshold energy in photoelectric emission. All these things are very important, and you may get numerical questions based on these. And of course, there was a question on quantum numbers last year. A question was there on quantum numbers. So that is obviously very important. The importance of quantum numbers and the permitted values of quantum numbers and so on. Question of various types may be asked on that. And apart from these, there are other important topics too, which you have to refer and study well to face the examination, the coming examination. For example, the probability density distance graphs and calculation of the nodes, angular nodes and radial nodes of orbitals, and calculation of the radius, the Bohr radius, the radius of the orbit, velocity, energy of electron in hydrogen-like atoms and ions, frequency, wave number, wavelength calculation of the various lines in the hydrogen spectrum, etc. These are important in the chapter atomic structure. Now coming to the next family, that is next chapter, that is chemical family, the periodic classification of elements. Most of the questions asked for conceptual questions, theoretical or theme-based questions only. There is not much scope for numerical questions, but remember there is always scope for statement type questions and assertion reason type questions and even match type questions in this chapter. 2017, it was electronic configuration of the element 114 and to indicate its group number and family number. In 2018, it was again about electronic configuration, and from the electronic configuration of two elements, how to write down the molecular formula of the compound formed between the two. That was a question. And then there was another question on the correct order of atomic radii of group 13 elements. In 2019, it was order of first ionization enthalpy of second period elements. That was asked. And in 2020, it was naming of the elements beyond 103. Of course, that is important. IUPAC naming of elements beyond 103. And then in 2021, it was a question on isoelectronic. You know what is isoelectronic pair? A pair in which the species have the same number of electrons. Isoelectronic means same number of electrons. So questions of various types may be asked. Among the following, which pair represents isoelectronic pair, or which group contain only isoelectronic atoms and ions, or isoelectronic molecules? So such questions may be asked. 2022, it was a question about the third, it was a very specific question about the third ionization energy of gadolinium. It is a very low value, and why is very low? It is based on the exchange energy values. And there was another question on the IUPAC name of the element 119, NEM will be the IUPAC name for element 119. Very simple. And the last year, again it was a very simple question, how the size of an atom is related to the size of the ion, size of the positive ion and size of the negative ion. The comparison of the size of the atom with the size of the positive ion and the negative ion. That was the question. So all the questions so far asked are easy questions. At the same time, you may also refer certain other aspects which have not been asked so far. For example, merits and demerits of the Mendeleev's periodic table. What are the advantages and disadvantages of Mendeleev's periodic table? And you also refer the concept of electronegativity, electron gain enthalpy, and also study about the order of the periodicity in the properties like metallic character, non-metallic character, the group-wise and the period-wise changes in these properties, and also study about the acidic nature of oxides of elements of a particular group, and basic nature of the oxides, acidic nature of the oxides of elements of a particular, and also thermal stability of compounds like sulfates, carbonates, etc. of elements of the first group or second group or other groups for that matter. So these are the important items in this topic, chemical family. So now coming to chemical bonding and molecular structure, as I told you in the beginning, a lot of questions were asked in the previous question papers of Neet 2019. There were as many as 3 questions. One question was about isoelectronic and isostructural species, a very standard question. And the second question was about the bond angles, bond angle variation in BCl3, PH3, ClF3 and NCl3. So what are the reasons for the changes in bond angles? So comparison of the bond angles in molecules like this. And the third question was based on bond order of diatomic molecules and ions. Almost a very sure question for many examination from molecular orbital theory, electronic configuration of diatomic molecules, their ions, calculation of the bond order, calculation of the bond energy or prediction of the bond energy, how is the bond order related to bond energy, how is the bond order related to bond length and so on, or how is the bond order related to stability of the molecule. Will a molecule of that type be formed? Will a molecule exist or not? If it is a bond order greater than 0, the molecule has existence. If it is 0, the bonding molecule doesn't exist and so on. So these ideas are very familiar to you, but you must refer these ideas once again and make thorough about these things so that you will be able to answer any question based on these ideas. Coming to the next question, here it is 2019. It was again molecular orbital theory and the number of bonds in diatomic molecules. Okay, axial and equatorial bonds and the bond angle in phosphorus pentachloride. Phosphorus pentachloride, you have the sp3 dehybridization, trigonal bipyramidal structure. You have the axial bonds and the equatorial bonds, and these bonds are different in lengths, corresponding to the bond angles are also different. So those things about PCl5 molecule was the question in 2019. So similar questions you prepare and be bold enough to answer any question relating to these ideas. Okay? And in 2020, it was about a molecule which doesn't exist. I already mentioned. And there was another question on dipole moment and structure. So how many of the following molecules will be polar? Or how many of the following molecules have dipole moment? Even organic molecules may be given. So for example, orthodichlorobenzene, paradichlorobenzene, metadichlorobenzene. Which of them has which of them has the highest dipole moment and so on. Questions of that type may be asked, or maybe simply inorganic molecules like HF, BF3, NF3, NH3, SO2, and you will be asked to predict how many of them are polar molecules, how many are non-polar molecules and so on. Questions of that type. Coming to 2021, it was hybridization and the shape of BF3. Of course, a larger number of molecules are usually discussed and try to be thorough with that, and also focus on the fluorides of xenon while you study these things, hybridization, structure, etc. of molecules like XCF2, XCF4, XCF6 and so on. And there were 2 questions asked in 2021 about the hybridization and molecule structure, and it was a match type question. You are given molecules and you are given the shapes, correct match, or how to get the correct match. You will be given options, and the correct match options will be asked, for which the mark will be given. Okay? So such questions are very common. Such questions are being commonly asked. Remember that 2022, there was a special question on the structure of diamond and graphite. What is the difference? Comparison of the bonding in diamond and graphite. And then there was a question on the bond orders of O2. That's a question which has been repeated any number of times. O2, O2 plus, O2 minus, O2 2 plus, O2 2 minus. And what is the order of the bond order? What is the order of the bond strength? What is the order of stability? What is the order of bond length? And so on. Okay, and then you will also get question on the magnetic properties of these species, whether they are diamagnetic or paramagnetic. So those ideas are important. And you may also get question on molecules with the lone pair repulsion, or comparison of the lone pair repulsion and lone pair bond pair repulsion, and working out the shape of molecules on the basis of the VSEPR theory. So there is also probability for such a question. And then in 2023, last year, you have got actually 5 questions on chemical bonding and molecular structure. There were 5 questions. One question was about molecules which do not have 8 electrons on the central atom, that is electron deficient molecules, or electron rich molecules having more than 8 electrons in the outermost orbit of the central atom. And then a question on order of energy of the molecular orbitals in nitrogen molecule. And then was a question on bond dissociation energy of hydrogen. And then was a question on intermolecular attractions. And there was also a question on Lewis acid molecule, that is molecule which are electron deficient molecule, like BF3 for example is a Lewis acid, and a molecule like NH3 which has a lone pair will be a Lewis base. So such ideas which you often discuss in connection with the coordinate bond, electron donation by one molecule and electron accepting by the other molecule. And the same thing you study as Lewis acid base reaction in acid base theory. And the molecule which accepts electrons is the Lewis acid, and the molecule which donates electrons is the Lewis base. So questions on such topics or such ideas may be asked. And apart from these, most of the topics were asked as questions in the previous question papers. Also, certain important items in this chapter: Fajan's role. What are the Fajan's roles? Okay, and the application of the Fajan's rules, and the concept of lattice energy, and the lattice energy and stability of ionic compounds, and the lattice energy and solubility of ionic compounds. So that aspect. And also important is hydrogen bonding in molecules, and how does hydrogen bonding affect the physical properties like a boiling point of compounds. And you have to differentiate between the 2 types of hydrogen bonding, particularly with regard to organic molecules, intermolecular hydrogen bonding and intermolecular hydrogen bonding, and difference in properties. So for example, orthonitrophenol and paranitrophenol. In the former you have intermolecular hydrogen bonding, and the latter you have intermolecular hydrogen bonding. So to what extent the boiling points are affected by these, and which one of these will have the lowest boiling point and which one will be steam volatile, and so on. Such questions are often asked on this. Now coming to the next topic, that is thermodynamics. Numerical questions, the scope for numerical questions, particularly based on the delta H equals delta U plus P delta V relationship, and delta U equal to Q plus W relationship, or you have the relationship between free energy and equilibrium constant. You have the relationship between the free energy and E0 cell of an electrochemical cell, and so on. So various relations are there, and based on that, numerical problems are very often asked with the 4 answers given, which is the correct answer. So anyway, in 2017, there was a numerical problem relating to the change in delta U in adiabatic expansion. And there was also another numerical question based on the spontaneity of reaction, probably delta G equal to delta H minus T delta S calculation, from which you can find the temperature, or if you are given the parameters, you can calculate delta G and suggest whether the reaction is spontaneous or not. The sign of delta G will tell you the spontaneity of the process. Okay? In 2018, it was bond dissociation energy and delta H for reaction. How is the delta H of a reaction correlated to the bond energies of the various bonds present in the reacting molecules. So there was a numerical problem on that. In 2019, there was a question on the work done in isothermal expansion of a gas. And there was a statement, there was another theme-based question giving you to find out the sign of entropy change in various processes. And then in 2020, there were two conceptual questions, one based on the free expansion of an ideal gas under adiabatic condition, and the second based on the sign of delta H and delta S for reactions. 2021, there was a question relating to the relationship between Cp and Cv. Cp minus Cv is equal to R, you know, for 1 mole of a ideal gas, and irreversible isothermal expansion of ideal gas. Both were theme-based questions, theory-based questions. And in 2022, there was a question in which pressure volume graphs were given, and a question was asked about the maximum work relating to the PV work. It was a theme-based question. In 20, it was a numerical question in 2022. And in 2023, the question was regarding a relationship between delta H and delta U, delta H equal to delta U plus delta N GRT. That is the relationship. So that was the question. It's a very simple question, standard question. Okay. So there were questions from almost all topics in the previous years. At the same time, there are certain other things important in this chapter. For example, delta H neutralization. And you know that for a strong acid, strong base neutralization, the value of heat of neutralization is constant. What's the reason for that? So that may be asked as a question. Again, the sign of entropy changes. You can study more examples in various processes. And you may also get a calculation based on Hess's law of constant heat summation. And sometimes you may get a question on which of the following are intensive variables, which are extensive variables, or which of the following are state functions, which of the following are path functions, and so on. Okay? Now coming to the next, that is chemical equilibrium. There were questions in 2017, 18, 20, 22 and 23, but there was no question in 2019 and 2021. And the questions asked were mainly relation between equilibrium constant of a reaction and equilibrium constants for stepwise reactions. If you express a reaction stepwise, and if you express the complete equation, in what way are the equilibrium constants related? That's a question. And then about equilibrium constant volume relationship, and there was also a question on heterogeneous equilibrium containing a gas in 2017. And in 2018, there was a question on Le Chatelet principle and how the principle is useful in prediction of maximum amount of the product in a given reaction. In 2020, there was a question, very important, the numerical calculation involving delta G0 and equilibrium constant. The relation delta G0 is equal to minus 2.303 RT log Kc. So that equilibrium constant, delta G0 relation. And in 2022, it was concentrations of various species given and calculation of equilibrium constant numerical problem. And last year, it was calculation of, again, delta G0 from equilibrium concentrations. From equilibrium constants, you can calculate the equilibrium constant, equilibrium concentrations, you can calculate equilibrium constant. And once you know the equilibrium constant, you can calculate the delta G0. Okay? At the same time, you may also refer the Le Chatelet principle based questions. For example, the addition of an inert gas. What is the effect of addition of an inert gas? So also you may refer. And then you also refer the degree of dissociation, calculation of degree of dissociation from density measurements in the case of decomposition equilibria involving gases, and also study the relationship between Kp and Kc, okay, and you can expect a numerical problem on that, and also try to study the relationship for Kp and Kc for heterogeneous equilibria. And then about ionic equilibrium, of course, there were questions in most of the years. Question on solubility product in 2017. It may be asked as a just derive the relationship for the solubility product, or in the next year it was a question to connect the solubility and solubility product. So solubility may be given, solubility product may be calculated. So such questions may be asked. And in 2019 also it was a question on solubility product, calcium hydroxide. The solubility product was given, from which you could calculate the concentration OH minus. And once you know the concentration OH minus, you can calculate the pH. So that was a question, 2019. And there was another question. There were two more questions. One was based on the Bronsted acid conjugate base concept, and there was a question on buffer solution. In 2020, again, there was a question on solubility and solubility product, and the importance of ionic product and solubility product. You know that when the ionic product exceeds the solubility product, the substance gets precipitated. So that you can connect this idea to the condition for a precipitation or the condition for crystallization. So there were numerical questions on that in 2020. And in 2021, there were questions relating to pKa, pKb, and pH calculation, particularly relating to salt hydrolysis. What is the pH of such and such solution? What is the pH of ammonium chloride solution? Salt of a weak base and strong acid. Similarly, other salts may be given, and calculation of the pH values. It's a very important calculation. And then in 2020, it was the pH of buffer solution. You have the Henderson's equation and pH of acid buffer, basic buffer, and so on. So you study all those things, you are likely to get questions from that. And you may also refer the different types of buffer solutions, which I just mentioned. And you can also refer the concept of Lewis acids and bases, which I already narrated. And then you can refer the order of the strength of acids and what are the factors which decide the strength of acids. And you can also refer common ion effect and application of common ion effect for example, in qualitative analysis of metal cations. We have that concept in practical chemistry, and this time practical chemistry has been included. So also give focus on these ideas relating to practical chemistry, precipitation of cations, what are the conditions, what are the reagents used, and what is the importance of solubility product and a common ion effect in the precipitation of metal ions from solutions in salt analysis. And then it was purification and nomenclature, chapter number 8. And most of the years there were questions. In 2017, separation of orthonitrophenol and paranitrophenol. I already said about it. The separation is steam distillation, orthonitrophenol. Boiling point is less because intermolecular hydrogen bonding, it exists as discrete molecules and not as associated molecules, as in the case of paranitrophenol. And therefore the boiling point is less. The substance is steam volatile and can be separated and purified by steam distillation. And there was a question on IUPAC name. Of course, in organic chemistry, IUPAC nomenclature is important. You might have studied a vast number of molecules, but make sure that you will be able to answer this question without making any mistake. So always observe the molecule very, very clearly and try to give the correct name of a compound. Then there was a question on paper chromatography in 2020. Paper chromatography. One point that you have to remember about paper chromatography is that the paper is not actually the fixed phase. It is the water on the paper. Water on the paper which is the fixed phase. That means the fixed phase is the liquid, that is water. And the mobile phase is the solvent carrying the solute molecules. So it is an example of liquid-liquid chromatography. The solute is getting, the mixture of solutes are getting partitioned between the two liquids, liquid, the fixed phase, and the liquid which is the mobile phase. So it is liquid-liquid chromatography. It is actually partition chromatography, you must remember. And in this context, you also try to understand about the RF values and the significance of the RF values and the conditions under which the RF value of a particular substance remains constant in a given experiment. Okay? And then there was another question on naming of a substituted alkene in 2021. And in 2022, there was a question on the Geldahl's method, estimation of nitrogen by Geldahl's method. And sometimes they ask even a question like this: which of the following compounds are not giving results in Geldahl's method, or which of the compounds cannot be tested for nitrogen, percentage of nitrogen in Geldahl's method? So that is a probable question. And calculation of the percentage of nitrogen is another numerical question that may be asked. And then a UPSC name question was also there in 2022. And in 2023, there was a question last year. It was a question on Lessene's test for nitrogen and what is the complex formed in the case of nitrogen, the ferric ferrocyanide, the formula of that, the oxidation numbers of iron outside the coordination sphere and inside the coordination sphere. All these things have been asked as questions in various years. So you may also refer important things in this chapter like a Dumas method, calculation of percentage of nitrogen, purification and separation method, especially steam distillation and distillation under reduced pressure. And you also refer the empirical formula, molecular formula calculation of organic molecules. And then it is isomerism and reaction mechanism, chapter number 9. And the questions asked were, in 2017, it was about the conformations of ethane. It is something that all of you know. In 2018, there was a question on the plus I effect of substituents, and also a question on the stability of resonance structures of nitro-substituted benzenes, resonance structures which is more stable, relative stabilities of resonance structures of a molecule. Then 2019, it was about electrophilic substitution, the mechanism of electrophilic substitution, what is a electrophile in particular, electrophilic substitution reactions and so on. And in 2021, there was a question on metamerism. You know the isomerism in organic molecules like chain isomerism, position isomerism, functional isomerism, and metamerism. And there was the question on metamerism in 2021. And in 2022, there was the question on pick up the molecules which are aromatic. Now, this is a question which has been asked for so many examinations, so many times. You will be given structures and you will be asked to identify which of the structures are aromatic, which are non-aromatic, which are anti-aromatic, and so on. Okay? And the conditions for aromaticity, you know, it is the molecule must be planar, the molecule must be cyclic, the molecule must contain the pi electrons conjugated, and the molecule must contain 4n plus 2 pi electrons. So these ideas you keep in mind and try to work out as many examples as possible. You are likely to get one question on the aromaticity of molecules. And in 2023, last year, it was to count the number of sigma bonds and pi bonds in a heterocyclic organic compound. The question may be general. It may be any molecule. Any molecule may be asked to count the number of sigma bonds and pi bonds. Last year it was, I think, a pyridine molecule which was asked. Pyridine molecule or a pyrrole molecule may be asked. If it's a pyridine molecule, as you know, contains a nitrogen atom in the ring which doesn't carry a hydrogen atom. Remember that. And only here you have the CH bonds. So you have altogether 6 sigma bonds and plus 6 CH bonds. You have 12 sigma bonds and you have 3 pi bonds in a molecule of pyridine. So you must be able to work out the number of sigma bonds and pi bonds in any molecule for that matter. Okay? So that may be a question, a sure question for the examination. And of course, there was also the question on the Huckel's rule of aromaticity last year. And in this chapter, you may also refer the important thing, hyperconjugation, apart from the plus I effect, minus I effect, plus R effect, plus M effect, and so on. Hyperconjugation is also important. Perhaps you may get a question on how many hyperconjugated hydrogen atoms are present in the following molecule. Okay? Or which of the molecule has greater degree of hyperconjugated stabilization. Such questions may be asked on that. And there is always possibility for a question on tautomerism. Okay, tautomerism, the extent of enol content in a ketone, for example, to what extent enolization takes place. Okay, such questions may be asked. And you can also have question on reaction mechanisms in organic chemistry, free radical substitution or free radical addition, SN1, SN2 reaction, elimination. All these things are very important. So refer those details and study them very effectively so that you will be able to answer any question on that. At the same time, you also give importance to geometrical isomerism, the E and Z nomenclature of geometrical isomers, and also about optical isomerism, the number of optical isomers, and the concepts of enantiomers, the term enantiomer, diastereomer, okay, and racemization, inversion, and also about the R and S configuration, the absolute configuration of stereoisomers. All these things are important. You are likely to get questions on that. Okay? And the last chapter in this connection for the first year, it is hydrocarbons. And a lot of questions were asked in the previous years, mainly theory-based questions or conceptual questions. And only one time it was a numerical question. So some of the questions which were asked, 2017, the reaction, hydration of alkyne, the Markovnikov addition to a triple bond, and the formation of an aldehyde or ketone as a product. And then there was a question on the comparison of the acidic property of alkane, alkene, alkyne. Of course, the hybridization is different, and therefore the electronegativity of the carbon is different, and therefore the electron attraction is different, and based on that you will be able to explain the acidic property of alkyne, alkene, and alkane. It is the terminal hydrogen in an alkyne which is acidic, which is most acidic. Okay. In 2018, there was a Woods reaction, and there was a question on side chain chlorination toluene, followed by certain other reactions. And there was the question on Friedel and Krafft's reaction, and there was also the question on cumene, that is isopropyl benzene oxidation to give cumene hydroperoxide, which undergoes cleavage to give a phenol and acetone. That is something which has been asked any number of times for various examinations. So it was asked for Neet exam also. So concentrate on that. And sometimes you may get a question on hybridization of carbon atoms in a molecule. A molecule may be given which contains double bond, triple bond, etc. And also a ring compound sometimes. And you may be asked to find out the type of hybridization of the carbon atom in the molecule. So there were as many as 4 questions asked in 2018. In 2019, again, there was a question on the calculation of the sigma and pi bonds in a hydrocarbon containing double bond and triple bond. And there was a question on linear catalyst and its stereochemistry. You know, linear catalyst, if it is used for reduction of a carbon-carbon triple bond, remember it is cis hydrogenation, so that is the stereochemistry of linear catalyst. On the other hand, if you use the Burst reduction, it is trans stereochemistry. Remember that? And there was a question on ozonolysis, prediction of the products in ozonolysis. And there was also a question on addition of hydrogen chloride to alkene, the Markovnikov's rule. And if it is addition of hydrogen bromide to alkene, Markovnikov's rule, but in the presence of peroxide, anti-Markovnikov rule, and so on. So these things are really important for the exam point of view. In 2020, there was a question on the stability of carbonium ions. Different carbonium ions or carbocations were given, and you were asked to predict the order of stability of carbocations. So that is important. There was again a question on Wood's reaction, and there was a question on alkene ozonolysis. So such things are being repeated. The Wood's reaction is being repeated. The ozonolysis is being repeated. The order of stability of carbocations being repeated. The number of sigma bonds and pi bonds in structures. So such type of questions are really important. Remember that. And in 2021, there was a question on the conformations of ethane and the dihedral angle. Okay. And there was a question on the addition of hydrogen bromide to alkene. I just told you. And 2022, there was a problem based on ozonolysis and product. Now, there is a trend for questions of that type in organic chemistry. For example, the mass of the starting compound may be given, and the mass of the product may also be given, or the mass of the product will not be given, and you will be asked to calculate the mass of the product formed. So it is again stoichiometric calculation based on organic reactions, which may be asked. So there is a trend of such questions being asked, particularly in JEE examination where you have numerical questions. They ask questions of this type based on organic reactions and the stoichiometry of that. And the Neet question paper also may contain similar questions in future. You may also refer topics like decarboxylation, Colt's electrolysis, Friedel and Kauf's reaction, and the base test for unsaturation with the dilute alkaline cheminophore, hydroxylation it is, and stereochemistry of hydroxylation, that is cis hydroxylation. Such things also you refer. And acidic property of alkynes, we already mentioned examples, and the test for acidic property of the terminal acidic hydrogen in alkynes, the reaction with ammoniacal silver nitrate and or Tollens reagent to give white precipitate, and the reaction with ammoniacal cuprous chloride to give red precipitate. These are tests for terminal acidic hydrogen in alkynes. And also refer about the Grignard reagent, and to find the number of active hydrogen atoms in molecules using Grignard reagent. The R part of the Grignard reagent will take the active hydrogen forming a molecule of hydrocarbon. So finding out the number of moles of the hydrocarbon that is formed, you will be able to predict the number of active hydrogens in a molecule. And also study about Birch reduction, linear catalyst, and the stereochemistry of those reduction reactions, which I already mentioned. So this is the 10th chapter in first year portions. Let us stop the discussion for a while, and we'll continue with the second year chapters soon.